Hi, this is Dr. John Bergduff, Professor of Mathematics at Lone Star College, Sci-Fair. As you begin a course in algebra, you're going to see very quickly that there's a lot of talk about equations and solving equations. In fact, we're going to spend a great part of this semester looking at different kinds of equations and how to solve them. It would be really good as we get started just to have some good background information on what that means exactly. What is an equation? What does solving an equation mean? If we have that kind of background, then as we look at different kinds of equations and different techniques for solving, I think you'll be able to see how it all connects together. So this lesson will be very, very basic, but we're going to explore some words that get thrown around in mathematics all the time, and I hope that the process will give you a good foundation. Let's get started. First thing I want to talk about is what is a variable? Or in other words, why do we have to have letters in math class? This is a complaint that you'll hear all the time. Everything in math was fine as long as we worked with numbers, but as soon as you started putting those letters in there, I didn't know what that was all about. This isn't an English class. So why do we have letters in math class? The letters are actually called variables. A variable is a placeholder that can be replaced by a number. And we usually represent variables by letters. Now, when I'm talking to future teachers about introducing the idea of a variable to very young children, elementary school age children, I tell them to think of a variable as more like a box. So in algebra, we do use x's and we use y's, but think of them instead as a box. A box where you can just put a number. You can put any number in that box that you want. You can put a 5 in there. You can change your mind. And you could put a 4 in there. Any number that you choose. So as we talk about variables in the future, think of them as actually being more like a box where you can place numbers. With the idea of a variable, we can build to the idea of an algebraic expression. What is that? An algebraic expression is a collection of numbers and variables connected by operation symbols and possibly grouping symbols. What do I mean by operation symbols? The most basic ones are the ones we know from basic mathematics: adding, subtracting, multiplying, which in algebra we usually represent by a dot instead of the X shape, and dividing. But operation symbols could be more than that. It could include square roots. It could include powers, like an x squared. It could include a lot of different things, and we'll see a lot of different things in this semester. What's meant by grouping symbols? Grouping symbols are simply parentheses. Parentheses convey the idea of let's do this first. So what would an algebraic expression look like? Here's some examples that might help. Here's a pretty simple one. 3x plus 5. Now, here's the thing that we have to understand in mathematics. When you have a constant written immediately in front of a variable with no obvious connection between them, there's always an understood multiplication going on. So 3x plus 5 really means 3 times x plus 5. What do we have here? We have a couple of numbers. We have a variable, and they're connected by operation symbols, one multiplication and one addition. That's a simple example of an algebraic expression. This one is a little bit more complicated. It can have an exponent. It can have a square root. And don't worry if some of these concepts seem a little bit maybe like you haven't seen them in a long time. We're going to be delving into that as the semester goes along. There can be fractions, And you can even have some parentheses to convey the idea of grouping. Maybe 5, and again, with nothing written in here, there's an understood multiplication, times x minus 3. The parentheses convey the idea that that goes first. So those are examples of algebraic expressions. One very, very simple, one pretty complicated. Let's focus on the simple ones for a little while. Next step, what is an equation? This is actually, you'll see as we go through the semester, really, really critical to be able to notice very simply what the difference between an equation and an algebraic expression is. Going back, just as a reminder, an algebraic expression is a collection of numbers and variables connected by operating symbols. If you look carefully at what I've written here, you don't see any equal signs. And that's the key difference. An equation is a statement that two algebraic expressions are equal. So what makes the difference between an equation and an algebraic expression is the presence of an equal sign. Here are a couple examples of equations. 3x plus 5. Oh, that looks terrible. 3x plus 5 equals 11. That's an equation. Two very simple algebraic expressions. The one on the right is nothing more than a single number. This one's a little bit more involved, not too much. 5 plus 3 times x plus 2 equals 7x minus 4. Each side is an algebraic expression. When you have the equal sign, you're saying the two algebraic expressions are equal, and that makes an equation. As the semester goes along, our equations will become more involved. We'll have things that look like this. We'll have equations that have square roots in them. And many, many other things. Again, we're going to start kind of simple. Okay, that's what's meant by an equation. What do we do with an equation? Well, this is another key word, solution. For the moment, let's just consider equations that only have one variable in them. We will change that as the semester goes along, in fact, pretty soon, and look at equations that have two variables or three or more. But for today, let's talk about equations with only one variable. A solution of an equation is a number which, when substituted for that variable, makes the equation true. Let's see what that means. Here is an equation that we looked at just a minute ago, and I want to make the claim that the number 2 is a solution of the equation 3x plus 5 equals 11. So kind of to go backwards here just a little bit, we've looked at the idea of a variable. A variable is a placeholder, a box, if you will, that you can place a number in. An algebraic expression is a collection of numbers and variables connected by various operations. An equation is a statement that one expression is equal to another. Here's where it all begins to tie in. If the number 2 is a solution, then what's supposed to happen is if you imagine dropping the 2 into the box where the x is, we should be able to check whether the equation is true. Let's do that. So let's look at my equation here. And for the time being, maybe just this one time, I want to think of the variable as being a box. And again, much like we've seen before, if there's no operation written, we have an assumed multiplication. 3 times the box plus the 5 equals 11. And if 2 is really a solution, then when I put 2 into the box, I should get a true statement. in checking whether it's true, we often put a little question mark above the equal sign. We're really asking, is that so? Is 3 times 2 plus 5 equal 11? Let's check. 3 times 2 is 6. 6 plus 5, yep, that's equal to 11. What we have just done is we have illustrated that 2 is a solution of 3x plus 5 equals 11. Putting the 2 in the box leads to a true statement. That's what's meant by a solution of an equation. Some numbers you put in the box will work, others will not. So, for example, I'd like to claim that 3 is not a solution of the exact same equation. What does that mean? This time I won't write the box. We have to kind of move beyond that. Once we kind of get up into the college level, we have to be very serious and mature at all times. But think of it as a box. In other words, I'm going to take the 3 and drop it in where you see the x, dropping it in the box to see whether it makes the equation true or not. Let's see. So I'm going to put the 3 in the box. I'll show it in a different color so you can see that there. 3 times 3 plus 5 equals 11. I don't know. Let's put a question mark there. We're going to check and see if it is or not. And let's do the algebra to check that out. So 3 times 3 is 9. 9 plus 5 is not 11. 9 plus 5 is 14. So that tells me that 3 is not a solution. That did not work. Let's look at another example just to get the idea of solution really, really sound. I'm going to show in my next example, or what I want to show is I want to show that the number 3 is a solution of this equation, x squared minus x equals 6. And this is going to let me bring up several things. This equation is actually, we call it a quadratic equation. We'll study it a little bit later on, just for the sense of getting these definitions of equation, solution, and so forth. It will be good. We actually won't see it again for a while. Let me look back a slide and notice something that I want to clarify. Notice that I said up here that I want to consider equations with only one variable, for now. And you look at this and say, well, I see 2 x's. What we mean when we say the equation only has one variable is that the two you can have an x appearing more than once, but you won't have another variable. You won't have an x and a y. Now that can happen, but for right now we're looking at equations in one variable, and the fact that the only variable that's mentioned is an x, even though there's 2 of them, that's what makes this okay as an equation in one variable. With the 2 representations of x there, that represents 2 boxes essentially, and I have to put 3 in both of those boxes. So what that would mean is dropping the 3 into the first box, I'd have 3 squared minus, and then dropping the 3 into the second box as well. So every x you drop a 3 in there equals 6. Again, we are asking ourselves if this is correct or not. We'll be talking about order of operations as we go along through the semester. Just as a quick reminder, exponents are always done before addition or subtraction, multiplication or division. So when you see that square, that means the first thing you'll do is you'll square 3. 3 squared means 3 times 3. 3 times 3 is 9, minus 3. Is that equal to 6? Sure is. So 3 is a solution of that equation. Now here's an interesting thing. Show that negative 2, I didn't mean to do that, I'll need that later, show that negative 2 is also a solution of x squared minus x equals 6. We're going to drop a negative 2 into this box as well. Now here, when we're dealing with negative numbers, is a situation where we really kind of have to think more carefully about that box. If I have x squared and the x represents a box, that means I want to simplify. I want to take everything in that box. I want negative 2, the entire thing, to be squared. In mathematics, if I only wrote this, I would only be squaring the 2, not the entire number that I'm putting in the box. So this will almost look like a box. What we do, instead of drawing a box, because again, we're supposed to be all serious and everything, is we use parentheses. Very important when you have a negative number to drop into the box. The parentheses sort of take the role of the box so that you're squaring the entire thing you're putting in the box, not just the 2. Negative 2 squared minus, let me kind of stay color consistent here, minus, and then in this box also, we'll do this for all negative numbers, negative 2, well, we'll talk about that in a minute, equals 6. Is that true? We'll put a little question mark there just to see if it's true or not. Negative 2 squared. Now, negative 2 squared would mean not just 2 squared with a negative in front, but negative 2 times itself. Negative 2 times negative 2. A negative times a negative is a positive. Negative 2 squared is 4. From your background in mathematics, you will hopefully remember that when you subtract a negative, it's the same as adding a positive. So negative 2 is 4 plus 2. Is that indeed equal to 6? Sure is. So guess what? This equation has 2 solutions. And it turns out these are the only 2. You might wonder, well, could there be a third one out there somewhere? But there really are only 2. Because we sometimes have more than one solution to an equation, it's very, very common to see a book ask you to write your solutions in a solution set. A set just means a collection of objects. A solution set just means put in one place all the numbers that worked, all the solutions that worked. We use set braces, these curly Q looking things, to represent a set. And for the example we just did, where we found out that there were 2 solutions, 2 numbers, which when substituted for the variable made a true statement, we'll put both of those in our solution set. They were 3 and negative 2, if you remember. As we'll see through the semester, some equations have 2 solutions, some have only 1, some have 5, some have many more than that, some have infinitely many. As we look at different kinds of equations, we'll see how all of that works. So, we've looked at what a variable is. Think of it as a box, a placeholder where you can substitute a number. We've looked at algebraic expressions, collections of objects, collections of numbers and variables joined by various operations, including parentheses. We've looked at equations, statements that 2 algebraic expressions are equal, and we've explored what's meant by a solution. I have one more definition that I want to look at before we finish this video. But the question that you might be asking right now is, how did he know to check the 3 and the negative 2? Life would really be complicated if this was simply like a guessing game. Gee, I'll just pull numbers out of the air, plug them in for the variable, see if they work or not. That would be very chaotic. We are going to see in future videos that there are definite processes, depending on what the equation looks like, for finding these solutions. And a word we're going to see very frequently is the word solve. To solve an equation means to find its solution set. For the first few lessons, we're going to focus simply on one type of equation. And not in this video, but in the next one, we'll begin to explore how we go about solving it, how we go about finding the solution set. Let's look at what that kind of equation is. We're going to be looking at what are called linear equations in one variable. Any equation that can be written in the form ax plus b equals c, where x is a variable, and the a, b, and c, they're not actually going to be variables. Those represent real numbers that I'm going to substitute in. Any equation that can be written in that form is called a linear equation in one variable. One particular rule or caveat or something that you have to hang on to is that the number a is not supposed to equal 0. If a were 0, that entire term would go away, the variable would go away. 0 times x is 0. That wouldn't be very interesting. So what are some examples of some linear equations? Well, we've actually already seen one. If you think about it, one of the equations we saw and we figured out what one of its solutions was. One of them would be 3x plus 5 equals 11. Notice that this fits exactly into this form. My plus sign looks terrible, though. Let me fix that. There, that's much better. 3x plus 5 equals 11. A, B, and C are 3, 5, and 11. They represent specific real numbers. The x is the variable. That's an example of a linear equation. Now, one thing that's probably good to mention right from the beginning, although we're using x's as variables lots of times, any letter will do. So another example of a linear equation might be, for example, 7y minus 3 equals 4. It's okay for a, b, or c to be negative. That still makes a linear equation, and you can have a different variable than y. What about this one? I'm using a p this time just for variety, and you might say, well, this isn't quite right because there's no b in there. Guess what? This is really all right. B can be 0. A cannot be 0, but B can be, so you can write that in that form. So that's a linear equation too. Here's a couple more. Maybe not quite so obvious. 3x plus 5 equals x minus 2. And you might say, well, that really does not look like that form at all. But the key word in that definition is the word can. The equation can be written in that form. We're going to find out, not right now, but in the next lesson, that you can write this in that form by doing an algebraic process that I like to call the principle of balance. Here's one that is not a linear equation. And we've already seen this one, as it turns out. X squared minus x is equal to 6. The fact that there is a square on the variable, there is nothing that you can do to get rid of that square so that you get this form here that has no square in it. That would not be a linear equation. Not that it's a bad thing. That's what we're going to call a quadratic equation, and we'll find out a little bit more about them a little bit later in this class. Anyway, I hope this lesson was a good introduction to some basic ideas of what we mean by a variable, an equation, how to find a solution, solving, and so forth. In future videos, we'll actually get down to business and try to see how we actually find those solutions. Hope this was good. Thank you very much. Bye-bye.